Okay, so I cut these out. Here's this cone, and when I cut it out and taped it, it should look like this with an open end base. And then here is the cylinder that I cut out, and then you just wrap it, and it has two open ends, so you can kind of see through it. But you tape it right along this line there. And when you do that, again, the important things about these three-dimensional shapes are that they have the same base, and mine are a little bit off, but like they should be relatively the same. And then also the same height here. So we're comparing two objects that have the same kind of fundamental dimensions to them, except one is this cone shape and has a slant, and the other is just straight. It's a cylinder, right? It's a prism. It has the same cross section. Okay, so again, I want you to predict how many of these does it take to fill up this, and maybe your prediction will change based on the previous experiment that we did. But so make a prediction. And Sam's here again. Sam now is predicting 3. Now, the other thing with this experiment is I'm going to pour from this one into here, and you kind of, because they're both open-ended, you kind of have to make sure that it's on a plate or something so that it doesn't pour out. Okay, so I'm going to pour this, and I just have rice in here, but you can use whatever kind of you have. It's a lot of salt if you're using salt. Okay, so there's 1. Okay. Here's another one. 2. And that didn't quite fill up because like this base was a little bit bigger. It should be 3, but I'm going to fill it up to the top because we're just doing an experiment. So measurement kind of makes these. So I get 3 and a little bit. If these were exactly the same base and exactly the same height, and we were measuring volume exactly, it would be 3 of these cones to fill up 1 cylinder that again has the same dimensions, right? Same base. So the base is pi r squared, whatever the radius of this is, and then the height is the same height.